So how do we actually measure this skewness if, let's say, we don't have the ability to graph or we don't want to graph, right? Well, we have two separate formulas. The first one that we have is called the Pearson's coefficient of skewness. This is the one that you are oftentimes going to want to use because it's easier, right? So this says that skewness, SK, is equal to 3 times the sample average minus the median all over my sample standard deviation. This is our simplest formula. Now, we also have a more complicated, more accurate formula, which we call the software coefficient of skewness. Our software coefficient of skewness is obviously not as simple as our Pearson coefficient of skewness, right? Our software coefficient of skewness has a n over n minus 1 times n minus 2 variable that we're scaling it with, and then we're multiplying it by the summation of all of the differences between each x value and that average divided by the standard deviation cubed, not squared, cubed. So our software coefficient of skewness is going to be much more elaborate. It's going to take many more steps. The textbook has a great walkthrough breaking every single little step of how to calculate this software coefficient of skewness. Since we have homework that is due tonight on this kind of stuff, instead of walking everybody through it, right? 16 people have already done the homework and completed it. What I'm going to do is I'm going to take a look at how everybody did on those particular problems where you were asked to calculate that coefficient of skewness and see if we actually need to review it in class or not. So we're not going to do an example of this right now. You are asked to do an example of both of these in the homework, and they are pretty straightforward, especially the simple Pearson one. Now, some characteristics of our skewness, right? So some characteristics are that the coefficient of skewness, right, this SK measure, can range from -3 to +3. If we have a value of -3, that's going to tell me that there is significant negative skewness. Significant. If we have a value of 1.63, that's going to tell me that I have moderate positive skewness. And a value of 0 here means that I have a symmetrical distribution. So the reason why it is -3 to 3 is because it's based on the cubed deviations from the mean. All right, let's go ahead and do a quick example of skewness just using that simplest formula. So a quick example just using the simplest formula. So we are given the earnings per share, the EPS, for 15 software companies. We are given them in the order of smallest to largest. We have 0.09. Just do this real quick. So in order to find the skewness here, right, our formula for the skewness has our sample mean, our sample median, and our sample standard deviation. So we need to calculate our mean, median, and then our standard deviation in order to calculate the skewness, right? So calculating our mean here, we're going to sum all of these up. Divided by the total number in the sample, not the population, lowercase n. So we sum all these up, we get 74.26. We divide them all by 15, and we get an average earning of 4.95. So we take this and we kind of run it through. We look at the data set and we say, well, there's a lot of zero values, a lot of values close to zero, but there's also some values, you know, above 10. So this does make sense. Passes the smell check, right? Passes the sniff test. And then we're asked to compute the median, right? The median is going to be the middle value in here. So since it's 15, right, we know that the median is going to be n plus 1 times 50 over 100 place. So we have 16 times 50 over 100. So we end up with half of 16. So in the 8th place, we have the median. So we count 1, 2, 3, 4, 5, 6, 7, 8. 8th place, here's our median. Questions on how we got our median of 3.18. Okay. We're going to calculate our standard deviation. Our formula for a standard deviation is that we're going to take the sum of the difference between each one and the average. We're going to square them, and we're going to divide that whole thing by n minus 1. And so this, we will unpack it just a little bit. And we end up with our first piece of data, right? Our 0.09 cents minus the average, which we calculated here, 4.95. And we square that. And then we add to that, we'll do the second one, just so we understand what's going on. We add 0.13 minus 4.95. And then we square that. And then we go dot, 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 because we're doing all of them, right? And then we go to that 15th one, that last value, which is 16.40 minus 4.95 squared. And then we divide this whole thing in the top by our n minus 1, and our n is 15 here, so it's divided by 14. So when we calculate this all out, we find that this standard deviation is equal to $5.22. So the average is 4.95, the median is 3.18, the standard deviation is 5.22. Given all this information, now we can plug this into our formula and get our Pearson coefficient of skewness here, right? We have SK is equal to 3 times X bar minus the median divided by my standard deviation. And so this is going to equal 3 times 4.95 minus 3.18 divided by 5.22. So this ends up giving us a coefficient of skewness of 1.017. We don't have to, but we can put a positive in here just to remind us that this is positively skewed. And we would say it's moderately positively skewed. That's what we would conclude about the shape of the distribution. Questions on our coefficients of skewness, how to calculate just our sample Pearson coefficient of skewness. So it's just using that stuff that we've been calculating this whole time, putting them all together, in this particular format, right? 3 times the average minus the median over the standard deviation.